Hello, students. Today we will study chemical reactions of aldehydes and ketones with nucleophile. So we know nucleophile is either neutral or it is negatively charged species. So all these reactions are nucleophilic reagent brings about reaction by attacking on positively polarized electrophilic carbonyl carbon in aldehyde and in ketone. We know carbon is it is positively charged carbonyl carbon and therefore attack of this nucleophile is easy. Today we will study this addition reactions of this nucleophile with aldehyde and ketone. First is addition of hydrogen cyanide, that is HCN. We know hydrogen cyanide is a weak acid. It add across carbon oxygen double bond in aldehyde and ketone and to produce a compound, and these compounds are called cyanohydrines. So these cyanohydrine compounds are the negative part of the reagent, that is Cn minus, attacks the nucleophilic carbon of carbonyl group, and reaction requires either acid or base as a catalyst. Now, first general equation. This is general formula for aldehyde or ketone, and when hydrogen cyanide is added in aldehyde or ketone, then this O group get bonded with hydrogen of hydrogen cyanide, and cyanide group is bonded to carbonyl carbon and forms this type of compound that is called as a cyanohydrine. We know if aldehyde is there, then R dash group here is a hydrogen called as a cyanohydrine of aldehyde, and if R dash group is alkyl or aryl, then it is called as a cyanohydrine of ketone. We will study examples of both aldehydes and ketones here. So first example is for aldehyde, that is acetaldehyde. Here R group is CH3. When treated with hydrogen cyanide, we get acetaldehyde cyanohydrine. So that is a product obtained with aldehyde. Here R group is hydrogen. Here it is wrongly printed because this R group taken here is a CH3. Again R group is shown here. So other group in aldehyde, acetaldehyde, is hydrogen. So here R group is replaced by hydrogen. That is a printing mistake. Then second example with that of ketone. Here the example of ketone is R group and R dash group are taken as a CH3, and therefore name of ketone is dimethyl ketone, or it is commonly called as a acetone. When react with hydrogen cyanide, then we get product called as acetone cyanohydrine. It contains carbon bonded to CH3 and CH3 group. Then O becomes OH and cyanide group get bonded to carbonyl carbon. So that is first type of addition reaction is addition of hydrogen cyanide. We get products called as a cyanohydrines. The second addition reaction of aldehyde and ketone is addition of sodium bisulfite. Sodium bisulfite have formula NaHSO3. So aldehydes and ketones, they react with saturated aqueous solution of sodium bisulfite and give crystalline precipitate of sodium bisulfite of aldehyde or ketone, that is called as a addition compound or adduct. Here the particular example is this is acetaldehyde, that is R group is CH3. When treated with NaHSO3, we get acetaldehyde bisulfite, that is addition product. Here the O group becomes OH and remaining group is SO3Na. So that is the addition product. Then next example is with ketone, that is sodium bisulfite and ketone. Here the reaction is, this is acetone. When react with sodium bisulfite, then we get addition product as acetone sodium bisulfite adduct. Exactly similar reaction to that of acetaldehyde. Third type of addition reaction is addition of alcohol. This is important reaction of aldehyde and ketone, because in this reaction we get this product, first product called as a hemiacetal and second product is acetal. These are the important compounds and therefore this is important reaction. Now when aldehyde react with one molecule of anhydrous monohydric alcohol in the presence of dry hydrogen chloride, then give alkoxy alcohol, and it's commonly called as a hemiacetal, which further react with one more molecule of anhydrous monohydric alcohol and give geminal dialkoxy compound. It is called as acetal. So formation of hemiacetal and acetal take place in two steps. So step number one is, this is aldehyde general formula. When react with this monohydric alcohol R-OH, reaction take place in the presence of dry HCl. Then this carbonyl group becomes OR, that is alkoxy, and the other group get bonded is OH from alcohol. So ROH is bonded like this, R dash with oxygen and OH group to the carbonyl carbon. So this product is called as a hemiacetal. In the second step, this hemiacetal react with one more molecule of monohydric alcohol, that is ROH, again in the presence of dry HCl. Then we get here RCH, here OR dash and other OR dash, and it is a stable product called as acetal, and the side product is H2O. So this is addition of alcohol that gives hemiacetal and acetal formation. Then here particular example we had studied now general equation. Now the particular example is, here it is acetaldehyde. It react with C2H5OH, that is ethanol, in the presence of dry HCl. Then we get hemiacetal, that is obtained by addition of one molecule of alcohol in aldehyde. So CH3CH, this O becomes OH, and this OH group from alcohol and O get bonded with C2H5, that is a alkyl group, and the product obtained is hemiacetal. It is unstable, therefore in the second step it immediately react with one more molecule of alcohol in the presence of dry HCl. Then we get here CH3CH, this is a common group from acetaldehyde. Then OCH3 is one of the group in hemiacetal, and one more OCH3 group get bonded to this hemiacetal and becomes acetal plus side product H2O. So name of this acetal is 1,1-diethoxyethane. 1,1-diethoxyethane. It is a geminal type of compound. So similarly, ketone react with alcohol in the presence of acid catalyst and form hemiketal and ketal. So similar to aldehyde, that is hemiacetal and acetal. Similar to this, ketone forms first this hemiketal and the ketal as a product. So ketone react with 1, 2 or 1, 3 diols in the presence of dry hydrogen chloride give 5 or 6 membered cyclic kettle. Here the reaction is, this is ketone, general formula RC double bond OR. When react with this dihydroxy alcohol, that is ethane 1,2-diol, in the presence of dry HCl, then we get product that is a cyclic kettle, that is RCr OCH2 CH2O. This is cyclic kettle formation, 5-membered ring take place here. The reaction can be reversed by treating with cyclic kettle with aqueous HCl and regenerate ketone. So this is addition of this alcohol in aldehyde and in ketone. The next reaction of aldehyde and ketone, before that, about this acetyl formation reaction. Here the acetyls and ketals are hydrolyzed with aqueous mineral acid and give corresponding aldehydes and ketones respectively. The last addition reaction of aldehyde and ketone is addition of Grignard's reagent. This aldehyde and ketone on reaction with alkyl magnesium halide, that is a Grignard's reagent, followed by hydrolysis, give alcohol. So we had already studied this reaction in alcohol topic as a preparation method of alcohol. We know that when formaldehyde react with Grignard's reagent followed by hydrolysis, give primary alcohol. Then any other aldehyde other than formaldehyde react with Grignard's reagent, give magnesium complex, which on hydrolysis give secondary alcohol. Similarly, any ketone that react with Grignard's reagent first give magnesium complex formation, which on hydrolysis give tertiary alcohol. So it is one of the preparation method for primary, secondary and tertiary alcohols. So these are addition reactions. Remaining reactions of aldehydes and ketones we will study in the next chapter, that is next lecture. Thank you.